Welcome to Chapter 4, Carbohydrate, Sugar, Starch, Glycogen, and Fiber.
Glucose, Part 1 by Professor Tammy. Learning objectives. 1. Describe the body's handling of glucose. 2. Identify foods that are rich in carbohydrates. Glucose for energy. A lot of this information on this slide is just a summary, something that you have heard already from this chapter. And some of them are just more information for you to know more about. Glucose for energy. Glucose is the preferred food source for brain and nerve cells. Liver stores 1/4 of glycogen in the body. And remember, glycogen is the stored form of glucose. Muscles store 3/4 of glycogen. Muscles hoard their glycogen for use during exercise, so they don't share. Muscles don't share their glycogen. Liver glycogen is energy enough to sustain the body for about 1 day. 1. The complete breakdown of glucose yields water and carbon dioxide. 2. Amino acids or proteins can be converted to glucose via gluconeogenesis. And remember, gluconeogenesis is when you don't have enough carbohydrate and you have extra proteins, and the protein is converted from protein to glucose. So glucose, new, genesis, to make. 3. Ketones are made from fat fragments when there is an inadequate supply of carbohydrates. Ketones are an alternative fuel source during starvation. Ketosis disturbs normal and acid-base balance. 4. Carbohydrate needs to prevent ketosis are 50 to 100 grams per day. 5. When glucose is abundant, that means a lot, and glycogen stores are full, the liver converts glucose to fat. So don't have too much of anything. Okay, remember, when you have a lot of glucose and then the extra is being saved to glycogen, and when the storage is full, then glucose gets converted to fat. 6. Proteins have their own job to perform that cannot be done by other nutrients. Fat stores are unlimited, so you can store as much fat as there is. The constancy of blood glucose. Steady supply in bloodstream. So in the intestine, food comes. In the liver, there's glycogen when it comes to the blood glucose food source through the bloodstream. Blood glucose homeostasis. Insulin moves glucose from blood into cells. That's how, you get energy. But if the glucose cannot get into the cells, that's how some people feel tired. Glycagon and epinephrine breaks down glycogen to glucose. Maintaining blood glucose homeostasis. When you have high blood glucose, it signals the pancreas to secrete insulin into the blood. So what this means is, if your body notices that you have a lot of glucose in your blood, it's going to say, hey pancreas, can you create some insulin and put it in the blood so we don't have so much glucose in the blood. So as far as the insulin, it stimulates uptake of glucose from the blood into the cells. So it helps the glucose from the blood enter the cell. So the storage of glycogen in the liver and muscles are important too. Conversion of excess glucose into fat for storage. That means if you have too much glucose, you fill up the glucose area, you fill up the glycogen area, and then where am I going to go? Oh, the fats welcome you. The end result is lower blood glucose, is because the insulin helps it, and insulin secretes inhibit it. So once your blood glucose is okay, then the insulin secretion stops. Low blood glucose signals the pancreas to secrete glycagon into the blood. So if you have low blood glucose, then glycagon goes, hey, we need to get this glycogen, this glucose storage, into the blood. So glycagon stimulates breakdown of glycagon from the liver and release glucose. Breaks down glycogen from the liver, and then it releases glucose into the blood. So remember, glycagon is the hormone that says, hey, glycogen, we need you here. So I'm going to break you down and make you into glucose. So the end result is to raise blood glucose. So glycagon's secretion is inhibited. So once everything's steady, glycagon secretion stops. Balancing with the normal range. Balance meals at normal intervals. Especially when you have diabetes, you have to really, kind of plan what you eat, because if you take medicine, then you have to kind of calculate your carbohydrates too. Diabetes, insulin either inadequate or inefficient. So that means you either don't have enough or it's not working, the insulin in your body. So there's two types of diabetes. Here is type 1 diabetes and type 2 diabetes. Type 1 diabetes used to be called childhood onset diabetes, or child onset diabetes, and type 2 used to be called adult onset diabetes. But in more recent years, children are starting to have type 2 diabetes, so they kind of changed their names into type 1 and type 2, because adult onset diabetes no longer applies to just adults only. It also applies to children. Hypoglycemia. So what to do if you have diabetes and all of a sudden you have hypoglycemia? This can happen sometimes when you're not consuming enough carbohydrate when you're eating, especially when you're taking medication, or you skip your meal. So it's really important for diabetics to have candy or a lollipop with them, just in case they start feeling dizzy or more faint. So that means that their insulin level is high and they don't have enough glucose in their blood. So they need to increase that glucose. That's why candy and lollipops come in handy for those who are diabetic. And it's not a secret stash, it's just to help them, because if they don't have that, the worst scenario can happen. Glycemic response. Glycemic response refers to the speed of glucose absorption, blood glucose levels, and return to normal glucose levels. Apples, corn, tortillas, and raw oats are examples of foods with low glycemic response. Blood glucose level drop rapidly after high glycemic response foods do an overcorrection. The usefulness and practicality of the glycemic index is controversial for several reasons. Watermelon and white rice cause blood glucose to rise rapidly. Following this, blood glucose levels plunge. GI, the gastrointestinal debate. High, medium, low gastrointestinal foods. So you might want to see the chart on the right.
See you soon. And remember to read the book.